Thanks so much. It's a lovely introduction. I'm super excited to be here today to talk to you all about AutoLayout's best practices. And just to give you a sense of where we're heading with today's tutorial, it's going to be 3 sections. The first section, we're going to look at AutoLayout and Interface Builder. The second section, we're going to look at AutoLayout in code, and then we're going to have a look at some debugging challenges and some tips and techniques that you might like to use in order to try and deal with some of those tricky AutoLayout issues that tend to come up when you're working with the technology. Now, a quick call out, no stress if you haven't already got this installed, but there is a prerequisite for this tutorial. You'll need to have CocoaPods set up on your machine and running. And so if you haven't done that, there's some information in the tutorial materials about how to get that set up. And I'll also give you another reminder kind of towards demo 2, which is when we're going to need that. Let's dive straight into our materials for today. So AutoLayout and Interface Builder. Basically, top tip number 1, or best practice number 1, is that simplicity is key. And this actually goes for AutoLayout in Interface Builder and also AutoLayout in code. But basically, a quick recap of what AutoLayout is, if you might be feeling a little rusty. It is pretty early in the morning still. AutoLayout is a system of constraints describing the arrangements of views on a screen. And you could basically think of it as a set of mathematical equations, and those mathematical equations kind of minimally describe the position of each view on your screen relative to one another, and then also relative to the super view that they're placed within to be presented, say, in your iOS app. So like all good mathematical equations and all good code, you really do want to keep things as simple as possible to make debugging efforts in the future a little bit easier. So leave the fewest number of constraints on your canvas at any given time when you're working with AutoLayout. Top tip number 1. Top tip number 2, best practice, stack views are your friend. And again, this goes for AutoLayout in code and also AutoLayout in Interface Builder. But basically, we have this wonderful class called stack view. You tell the stack view where it should be positioned relative to other views on the screen. And then you throw a whole lot of content, a whole lot of other views in it. And it's able to kind of deal with them in a very consistent manner, which is very helpful for you. Basically, you want to take a look at using stack views when you're aligning content in rows or columns. And that sounds a little bit obscure, but actually, working in e-commerce, we are constantly trying to align labels with text to the left, to the right, to the top, to the bottom. And so it does come up more often than you would think in practice. Another just really interesting call out for stack views is that even though they are designed to manage your content in a consistent way, you can actually use them in conjunction with specific AutoLayout constraints. So it's not an either-or proposition, you can use both together. So top tip number 2, when aligning content in rows or columns, consider a stack view first. Next up, quick call out. We're not going to look at this in the demos today, but wanted to call out that we have new in iOS 11 a safe area layout guide. And it's basically a replacement for aligning things to the top layout guide and the bottom layout guide that you would often do in a view controller. So this is available in iOS 11, but it is backwards deployable. And so if you have the opportunity to do so, changing everything up to use the safe area layout guide is a great idea. So it really just simplifies your process overall. Dynamic type, shout out for dynamic type. This is touted as an Apple accessibility feature that actually allows users at the system level to increase the font size on their phones and have that reflected in your apps. And it is touted as an accessibility feature, but actually a ton of people use this. So Etsy has millions of installs. We have a huge amount of our user base that actually has the font size cranked up at the system level, and that we would like our apps in general to be able to respond to that. Maintain relative kind of styling, but allow users to use larger text on the screen. And my personal theory is that basically a lot of people want to be able to reach to their phone and use it in the morning without putting their glasses on, so have the font size cranked up a little bit bigger. All new interfaces, really, if possible, you should be trying to design your interfaces with dynamic type in mind. It does require a little bit of coordination with your designer if you're working with a designer, just to try and decide ahead of time if text is going to overflow the area you've allocated for it, how that should happen, and what elements should rearrange on the screen in order to accommodate that. Similarly, you may not wish to have all of the text on your screen kind of dynamically alter. There might be some pieces of text or information that are more important than others, and in that case, you want to kind of allow those to resize and keep others the same. We'll take a look at that later in the demos today. Yeah, and last slide, just some useful key commands for working with AutoLayout in Interface Builder. I'd encourage you to try these out as we're moving through the demo today. Option command return and command return showing and hiding the assistant editor, super useful. Allows you to have like a storyboard and some code on the screen at once. Flip back and forth between those. Option command 0 is going to allow you to show and hide the right pane of Xcode. Super helpful when working in Interface Builder. Sometimes you want to see the whole canvas at once. Sometimes you're going to want to see the individual elements that you can kind of play around with. So a quick way to flip back and forth there is useful. And then in Xcode, you are actually able to create your own custom mappings for certain key commands. There's some information in the tutorial materials about how to go about doing that. One that I really like is command equals for update all frames. So that's when you've applied a couple of different constraints to your interface builder canvas, but perhaps the views that you have positioned on that canvas haven't adjusted yet to show you their relative position once the constraints are applied. So some useful key commands that hopefully will help you out. And with that, we're going to move to demo 1. Now, in our demos today, we're actually going to create a snakes and ladders game, and each of the demos is going to build upon one another to do that. So right now, we're going to take a look at setting up our board with Interface Builder. I'm just going to switch over to Xcode here. And for demo number 1, let's have a look at that on the screen. It's a little bit big. I'm going to do a lot of zooming today. Apologise in advance for any seasickness. I'll try and move slowly. We're going to go over to demo number 1, the starter project in the materials, and just double click on letters and snakes to open that up in Xcode. Okay, so here's our canvas. Just for all of the demos today, building and running is going to be the first step that we take. So just press Command R to build and run the project. And we'll take a little look at that and what that looks like in the simulator once the simulator launches. Oops, and that's a little bit big. Basically, what we have on the screen currently is what will later become our board. And actually, I might just stop this for a moment. I'm going to move, instead of the 8 Plus simulator, I'm going to move to the iPhone 8 simulator, build and run, and just see how that goes. Great. Okay, so with our simulator on the board here, I'm just going to close some of those windows behind it. It's a little bit better of a view. We've got our blue square, which will become our snakes and ladders board pretty shortly. But what I do notice when I launch the simulator is if I press Command and the right arrow to actually turn the simulator around, I'm going to end up with a board that is actually no longer square, which is not what I want. So in portrait orientation, we're doing fine, but once you move to landscape, we get a little bit stuck. And so we're going to take a look at some of the constraints that are in place to make that happen and what we can do to adjust them to maintain square in both orientations. So I'm going to hit stop to stop the simulator. I'm going to go ahead and take a little look at some of the constraints that are currently applied to the view. This board background is our blue area, so I'm most interested in the constraints that are applied to that. And I can see pretty quickly that we have a leading and a trailing constraint to the safe area that is probably what is causing this expansion in the in the landscape orientation. So the first thing that I want to do is just go ahead, select both of those items, and I selected both of those by holding the Shift key and hit delete. Now I notice when I do that that my dice image has jumped up the top. That's okay, we won't worry about that for the moment. What I'm interested in is actually creating a dual set of width and height constraints that are going to work together in order to maintain that square ratio. So to get started on that, I'm going to control drag between board background and the top level super view. And I'm going to press Shift and hold down equal widths and equal heights as my two constraints that I want to create immediately. I'm then going to click this Add Constraints at the bottom here. So that seems to have done something, not quite what we want, but that's a good start. And I'm actually going to repeat this action. So control dragging between board background and the top level view. Again, holding down the Shift key and clicking equal widths and equal heights. And this time, instead of clicking Add Constraints, I'm just going to hit Return, and that'll also create that secondary set of constraints. Now, with this board background selected, I'm going to move over into my attribute size inspector down here. I'm going to go ahead and take a look at this set of constraints that I've just created. Let's see if I can get my zoom levels right. Oops. A little bit tricky to do that. I might close up some windows here. But basically, I have two width constraints, equal width to superview, equal width to superview, and then two height constraints, equal height to superview, equal height to superview, which is good. This is what I want. Now we're going to make these constraint sets work together. The first equal width to superview constraint, I'm going to modify to not have a priority of 1,000, which says that it always must be happening, but I'm going to change this priority to 750 to say, where possible, please try and fulfill this requirement, but it's not critical. And then with the second width constraint, I'm going to say, okay, with this constraint, I do need this constraint to be fulfilled at all times, but I'm going to make it an inequality, so it's less than or equal to 0, and its priority remains the same. It remains a priority of 1,000. Now I'm going to repeat this action for the height constraints. So equal height to superview, going to give it a priority of 750 that says, please, where possible, we want the aspect ratio, sorry, the width of the board, or actually in this scenario, the height of the board, to be as big as possible. But if you can't do that, this aspect ratio, 1-to-1 ratio to board background, which maintains that nice squareness of our board, is the more important constraint to fulfill. And then equal height to superview. If for some reason we can't get the superview height to be exactly equal, we're going to have it be less than or equal to the size of the screen. So that's good. I'm starting to see on my canvas that things are looking a little bit more square, so this is good news. We do still have one error, so I'm going to zoom back out. Zoom back in over here. Let's take a look at what the error is, and it's a little bit cut off here, but it says basically that I need constraints for the X position, or the width, of this blue background. So to add that in, I'm going to go back to my board background, again control dragging between the board background and my top level view, and I'm just going to say center horizontally in safe area. And lo and behold, my constraints have all fixed up, which is excellent. I've got two sets of constraints that are now going to better operate in both the portrait and landscape mode. And I'll press Command R just to build and run that, and to make sure that things are looking a little better. So I'll go back over to my simulator. In my landscape mode, it's already nicely in a square, which is great, but let's have a look by pressing Command right arrow and just rotating through some different orientations. Great, and now we've got a square in all orientations, which is what I want. So first part of demo 1, check. Back to Xcode. The next thing that we're going to want to do, because this is a board game, we're going to want to put some squares on our board. And so instead of our beautiful dice image, we're actually going to delete that and start to add like a checkerboard effect into our board. Now to do this, we're going to use our friend UI stack view. So right down in the bottom here, it's a little bit small. Let's have a look. I'm just typing UI stack view. And you can see that I have an option of a horizontal stack view or a vertical stack view to be added in. For the moment, for our top level stack view, I'm going to choose a vertical stack view and drag and drop that right into the blue area of my canvas here. Oops, now when I dragged and dropped that, actually it didn't quite work. What I want to do here is to drag and drop it into the board background, which is our blue area. I'm going to move that up in our side navigation area here. I'm going to rename this, and we'll see why in a moment, rename this rows. And then I'm going to add some constraints to this top level stack view by using this button down in the corner here, add new constraints. So we'll click on that. Zooming it back out, and add 4 constraints, top, bottom, left and right, or leading and trailing, just to make sure that this stack view takes the whole width of our board. And you can see once I've applied those constraints that the stack view expands to fill the existing blue space. So next up, because we're trying to create a checkerboard effect with some rows and some columns, I'm going to drag and drop a horizontal stack view right into the middle of this blue area, and hopefully, yep, it has worked, so that's great, just underneath our rows stack view. I'm going to rename this stack view just by clicking on the text there to items in row 1. I'm going to control drag back out. Control zoom back out, and then I've got a nice horizontal stack view ready to place some squares into. Now I want to have 25 squares on my board in total. We're going to do 5 by 5. And so to actually, for an individual square, I'm going to start to, in this bottom area, there we are, type view and scroll down all of my options at the bottom of this control selector, click on my view, and then drag and drop just one view for the moment into my items in row 1, horizontal stack view. Now, because I'd like this checkerboard to have a bunch of squares on it, I'm going to immediately apply an aspect ratio constraint to this square, and this view is going to start to kind of form the basis of our checkerboard. And while we're here, I'm just going to rename this to square. Makes it a little bit easier to deal with if we've got sensible names in our left-hand pane there. Now, at the top here, we're going to look at the identity inspector, I think it is. Let's see if I've got that right. Yep, the identity inspector in the top right-hand pane. I've predefined a class that we're going to use for this square called board square view loader. So I'm going to add that in as our class. And then if I click not the left, but one icon to the right, we have under board square view loader some custom properties that I can fill in an interface builder. So we're going to go ahead and fill those in now. The first new name is going to be board square view. Because this is going to be a numbered square on a checkered board, the number text, this is going to end up as our last square on our board, so the number text is going to be 25. And then I'm going to add the description text of finish to the board. And you can see when I enter in those properties, things start to happen on our canvas, things start to happen in the square that we've pre-prepared, so that's great. I'm also, while we're here, just going to choose a more interesting color scheme for this particular square, so I'm going to make it purple. And that seems pretty good. We've got one of what will now be many squares. Because this horizontal stack view is items in row 1, I'm actually going to just copy this square that I've now created and have 5 squares reaching across our board to start with. So Command-C to copy that square view, and then Command-V 4 times. Command-V, 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 Command-V. So we've now got what will become 5 squares on one row of our board. Now, a couple of things to change up because we do want that nice checkerboard effect. I'm going to select squares 2 to 4 here. And we had previously added in some kind of number text for our squares, but we don't want that to be happening for squares 2 to 4. So I'm just going to delete the text out of those properties there. And you can see eventually Xcode Interface Builder Canvas will update to reflect that. Next up, you'll notice that these errors are occurring because we can no longer maintain that nice squared aspect ratio. That's okay. We will be resolving that in due time. But the next thing that I'm interested in is actually making a more interesting color pattern happening here. So I'm going to select squares 2 and squares 4 by pressing Command and clicking. Oops, 2 and 4. And I'm just going to change the background color using this background selector over here from purple to something a bit more interesting. We'll go back to blue. So we're starting to see the beginnings of a checkerboard effect. We have items in row 1, so that's looking good. I'm actually going to close up this little twisty over here now and just Command-C to copy items in row 1, and we're going to create 4 other rows to match on our board. So Command-V 4 times, 2, 3, and 4. And I'm just going to rename these items. So items in row 2, oops, items in row 3, items in row 4, and items in row 5. And you can kind of see on the right-hand pane there, we're starting to get what looks a little bit more like a checkerboard. I'm going to go ahead and open up some of these twisties. Not sure if that's the official term, but we'll go with twisty. And then for the first square in each of row 2, row 3, and row 4, and row 5, I'm going to, oops, let's try that again. I seem to have too many things selected. So row 2, row 3, not the second square, the first square, 4 and 5. We'll select those. We're going to, again, remove the number text that I'd previously added to make our board look a little bit more sane. For this square over in the corner here, which is going to become the starting square on our checkerboard, I'm actually going to add some different number text back in. So I'm going to call that square number 1, and the description text for that square will be start. And then the last thing to do to make this look a lot more like a real checkerboard is for the even numbered rows, we're going to change up the colouring scheme. So for row 2, I'm going to select squares 1, 3, and 5, and instead of those squares being purple, we're going to make those squares blue. Ta-da, checkerboard effect starting up. And then similarly for squares 2 and squares 4, we're going to make those purple. Great, so this is more of the pattern that I want. I'm going to go ahead and do that for items in row 4 as well. So 1, 3, and 5, not purple but blue. And squares 2 and square 4, not blue but purple. Great, so this is looking much more like a checkerboard, a board game, something that I'd like to use. Command and R just to build and run that and take a little look at what's happening in the simulator now. Great, so I have something that looks a lot more like a snakes and ladders board, and I'm just going to press Command right arrow just to make sure things are maintaining that square position. Great, now the final thing that I want to do for demo 1 is we want to have a look at dynamic type. So actually I'm going to build and run that project in the simulator again. I'm going to hit Command-Shift-H, which is simulating tapping the home button, if there is a home button on the device. Moving into settings, then selecting general accessibility, and under larger text, I'm actually going to flip this on. Now, this might be a little bit tricky. So we've actually flipped on our larger accessibility sizes. And what we will be doing now is just taking a look at what happens when we move back to our application and review our board. You can see nothing's happened here, but what we would like to happen is actually the number to increase in size. So we're going to go ahead and have a look at doing that in the simulator now, in Interface Builder now. So moving back to Xcode, stopping the simulator. I happen to know, I'm going to press Command-Shift-O. We had a look at the board square view loader before, but the zib name that we provided to our square on our checkerboard is boardsquareview.zib. So we're going to open up that file. Take a look at what we have here on the canvas. So 2 labels, 1 number label, 1 description label. And it's our number label that I'd like to actually make, whose text I would like to make dynamic. So we're going to zoom in over here on our font, press this little text button to the right of our font selector. And instead of these system fonts, I'm actually going to make this headline and click done. And then I'm going to make zoom in on this dynamic type option and just check this automatically adjust font button here, or checkbox here, which is super helpful. And then while I happen to be here, I'm having to notice that I have 2 labels. They both have a bunch of constraints applied. As we mentioned earlier, stack views are a really clean and easy way to kind of organize content in a logical manner. And so instead of 2 separate labels with a bunch of constraints applied, I want to select both of my labels and actually incorporate them into a stack view. And there's this handy little button down here that with the label selected, I can click to say embed in stack. On our canvas now, we have the 2 labels within a stack view. And I'm going to go ahead and just add 4 constraints to that stack view just to make it fill up the space on my board square. So adding those 4 constraints, I'm now ready to check out my dynamic type again. So Command R to build and run. Moving over to our ladders and snakes game. And we'll notice that our text size has just slightly increased, which is what we want for this scenario. So we've now implemented dynamic type for our snakes and ladders board, and we're ready to move on to the next section of our theory. Having completed demo 1, we're now going to move along, and we're going to take a look at AutoLayout in code. Whoops, trying not to trip over my folder there. As promised, here is your official warning. If you don't have CocoaPods installed, here is a quick way to try and get that set up on your Mac. Or you can go ahead and take a look at cocoapods.org for instructions if you've come in late or you haven't got that set up just yet. But moving along to some theory. So we're now going to take a look at AutoLayout in code. And just a quick recap of a bunch of different ways you can create AutoLayout constraints in code, and some kind of pros and cons of each approach and when you might like to look at doing so. So a quick reminder here, NSLAYOUT constraint is kind of your original, your most verbose, probably lowest level way of creating a constraint in code. And you'll see here from the properties that you pass into a constructor here, it's pretty granular and very, very verbose. It doesn't make for nice, pretty concise code. But it is one way to create constraints in code. Next up, we have the visual format language, and this is a little bit more interesting. It's a little bit more concise, and in this particular example, you can see that we are creating two different formats that then generate constraints for us in code. The first format, keeping with the snakes and ladders theme, in the sibling view format there, we have a green snake, a purple snake, and a red snake as our views, and we're trying to create constraints, constraining them relative to one another. In our super view format, we've then got a purple snake being constrained to its super view. Having created this language in these format strings, we pass them into a NSLAYOUT constraint.constraints constructor. Generate some constraints, and then we're able to activate them. Interesting, I still find this fairly complex to be reading at any given time. One thing that Apple does say, which I think is really interesting about the visual format language, is that even if you don't use it to generate your own constraints, it is really important to understand a little bit about what's going on with VFL, because it is the way that if an error is printed to the console for AutoLayout, you're actually going to see VFL incorporated into that error message. So they don't necessarily, I don't think, from the documentation advocate writing constraints in this manner, but hey, if you enjoy the format, please feel free to go ahead. NSLAYOUT anchor. This is getting a little bit more concise again, a little bit more useful, and it's as though the people creating AutoLayout at Apple have kind of realized that there's some pretty basic use cases that cover about 90% of the constraints that you will going to want to generate at any given moment. So layout anchors really focus on points that are really common to constrain to different areas. Top of your view, the bottom of your view, left and right-hand sides, and also the center of your view. And this is a little example. This little function is basically taking in a view that we want to constrain the view that the function is called upon to one another. So here we're trying to constrain the center Y anchor of one view to another. It's a little bit less verbose, and we'll see a little bit more of this in use in the demos. And then you also, getting higher level and probably more concise again, you have the option of using a third-party library to generate constraints in code. So there are a number of popular third-party libraries out there. Snapkit is one of them, PureLayout is another. All of them are quite good, and any of the relatively well-maintained libraries I would totally recommend. This just gives you a sense of how to use Snapkit. It's a pretty quick example, but here we're creating some constraints on a player token view. We're importing Snapkit at the top of our file, and then all we need to do to make constraints is to say playerToken.smp for snap, .make constraints, and within the closure here we're able to make constraints using make, which is of class constraint maker. Reads like English, we're making a center X equal to the current square, which is another view defined in this particular example, and also center Y, and it's pretty clean, less verbose again, highly recommended if you've got a lot of constraints happening in your projects, something like this. Great, so given those couple of approaches, like which should you use and when, I've touched on some of this already, but basically NSLAYOUT constraints, try and avoid them if you can. They're required, I think, in some scenarios for extreme granularity, but in practice, they're not a really common use case. Visual format language, useful to know if you enjoy the kind of format that's being created there. You can go ahead and use that. My personal recommendation is NSLAYOUT anchor or a higher level third-party library. But sometimes what people will do, if they are not interested in having a third-party library in their project, they're going to take one of the first three options, create some abstractions over the top of it and use that in their project because they'd like to maintain most of their auto layout code themselves, and that's fine as well. Great, so with that, we're going to move to demo number 2. Returning to our ladders and snakes theme, we're now going to start to put some obstacles on our board. So we're going to move back to Xcode for that. Now, as promised, we're going to move to Demo 2 Starter Project, which I'll just open up here. But you will need to go ahead and open up Terminal as a starting point. And I'm going to first move into the starter project for demo 2 just by typing CD and dragging in the location for demo number 2. And then you're going to need to issue the pod install command. And all we're doing here is using CocoaPods which is a third-party package manager, to install SnapKit into our project because we want to take a look at that and using that pretty shortly. And this has worked, which is great. It's also instructing us, as all good pod install commands do, to now go ahead and open up the XC workspace file for this project. And so we'll move back and double-click on that to bring that up in Xcode. Great. And just to start this off, Command R to build and run the project, and we'll see where we're at getting started with this demo. Yeah, so what we have here is our board in the simulator. You can see that we've gone ahead, or either yourselves or a colleague has gone ahead and filled out all the rest of the squares on our snakes and ladders board. And the only thing that's really different, much different from our previous attempt here, is that some of our labels have just been flipped to the other side of the board, and that's to make way for our obstacles that we're going to place on the board pretty shortly. Now, to get started with our snakes and ladders game, we're going to add some ladders as our first item. So our main view controller for this project is going to be board view controller. But actually, before we go to that, I'm going to Command Shift O for orange, not 0, and open up ladderView.Swift, which is a class that I've prepared earlier. And in ladderView.Swift, down the bottom here, this is basically an extension of a UI image view. Shout out to Vicky Wenderlich. She's created some lovely lovely images that we're going to incorporate as obstacles in our board. Here, what I have already for you is a creation function, just a little factory method that's going to create and return a ladder view. And we have basically the ability to set some properties because we're going to take the one ladder image and either flip it around or rotate it a little to make different obstacles on our board. You can see that we've defined a few protocols, sizable, rotatable, and flippable in order to do that. We're also doing some things like adjusting alphas so that we can fade in all of our obstacles at an appropriate time on our board. Now, we want to go ahead and make use of this new ladder view that we have created, and I'm going to return Command Shift O for orange to our board view controller. And in our board view controller, this is our main view controller for our application. And we're going to just jump down to the bottom of the file here under ladders. We're going to create a function, and we're going to call this function, what am I going to call this function? Add right leaning ladder to. Right leaning ladder to view. You'll see I've already got a different function that we'll use a little bit later on, defined below. And we're not always going to want to use the result of this function, so I'm going to add discardable result annotation to this method here. Now, next up, in creating our ladder view or making use of our ladder view creation method, we're going to provide some sizes to it, and we always want the sizes of our ladder view to be relative to the size of the square on the board. So I'm going to define a variable called span here, which is relative to the size of the width of a square on our board. I'm then going to go ahead and create a ladder view.create, providing a size, which is going to be span. And because this is an explicit function talking about adding a right leading ladder or a right facing ladder, I'm going to give it a direction in its creation of faces right. I'm then going to go, little bit off with my typing there. Then going to go ahead and add the ladder that I've just created as a subview. And just to silence the error coming from this method, I'm going to return the ladder. So that's all good. I have a ladder ready for use. Next step is to actually place the ladder on the board and kind of give it some auto layout constraints. So I'm going to go ahead and do that. We're going to use NSLAYOUT anchors for this example. Let guide equals views.layout margins guide. We're then going to center Y anchor this particular ladder constraint. And we're going to say that it's equal to the center Y anchor of the guide. And we're going to offset a little bit with a constant. So the constant in this scenario is going to be negative square width, which just means it's going to sit nicely on our board. And then, oops, before I finish that up, we're going to say is active equals true to make sure that the constraint is activated. And I'm going to go ahead and do something pretty similar for our right anchor. Constraint. Again, it's going to be equal to the right anchor of the guide. Oops, guide.right anchor. And we won't offset that with the constraint, but we will say is active equals true. Great, so that's looking pretty good as a method to add a right-leaning ladder to our board, but we're going to go ahead and use it. So I'm going to move back up to the top of the view. I have a method here called add obstacles to board. And I've already attempted to add some obstacles to a board. We know that that's not working based on the board that we've seen, but we'll come back to those methods later on. And we're going to say let ladder equals add, actually instead of ladder, I'm going to call it let right equals add right leaning ladder to board. And then I'm going to go ahead and just add it to this obstacles array here as well for good measure. So that looks pretty good. I'm going to build and run the code that I've just written, make sure that we work and see what's happening. Okay, so I do have a ladder on the board, so that's good. But the ladder is way too big for my board, so we're going to go ahead and take a look at that now. So I'll stop the simulator again. Now, where we are just returning to the add right leaning ladder method, we can see that, okay, all of this looks good. We are positioning things correctly. If we go ahead and take another little look at create, with our creation function, we are trying to add some size constraints to the ladder, but they don't appear to be working. And if we look into this add size constraints method, it's because we will be adding this as part of demo 2. So I'm going to go ahead and this time I'm going to use the visual format language to add some size constraints to this view. Now what I want to start with for this scenario is setting translates auto resizing mask into constraints to be false. And this basically says, okay, system, please let me do the kind of resizing, the constraint adding here. I don't want you to automatically generate anything based on the auto resizing mask of the view. And it's pretty common to forget this, and it causes all sorts of nasty errors into the console. So quick shout out, whenever you're going to add a lot of explicit constraints, you want to just ask yourself, have I set that to false to start with? Okay, and what we're going to do next is whenever you're using the visual format language, you actually need to define this little views dictionary that just says, here are the views that I'm going to operate on, and what should I call them in following formats that I'm going to use. So here we're going to operate on self, which is the view that this add size constraints method might be called upon. And then I'm going to go ahead, because we're interested in sizing here, we're just going to define a format which is width format. And this will just be a string. And we'll now refer to self as sizable in our subsequent format. And we're going to say that sizable, from the width perspective, should be equivalent to the width that we've passed into the method. So that's format string number 1. We're going to then look at a height format. And because we're looking at height, we need to tell our system that we're operating in a vertical capacity. So I'm going to add a v colon to the start of my format string here. Oops, sizable. And from a height perspective, we're going to have sizable be equivalent to the height that we're passing in to the method. So great, I've got some formats. I now need to convert them into constraints in order to use them. So like we saw in our theory slide, let width constraints equals NSLAYOUT constraint dot constraints. And then we're going to use this constraints with visual format. For our width constraints to be generated, I'm going to pass in our width format. I'm not going to worry about our options here. Metrics I'm going to set to nil. We don't need to worry about anything to do with metrics right now. But I am going to say that the views that we've operated previously with will pass in as our final parameter. I'm going to do something very similar now for our height constraints. NSLAYOUT constraint dot constraints with visual format, height format. Again, not worrying about options, so oops, just removing that altogether, setting metrics to nil, and then passing in our views dictionary that we've previously defined. And the last thing left to do is to gather up all of our constraints, so all equals width constraints plus height constraints. And then we're going to activate these constraints. So NSLAYOUT constraint dot activate. And passing in all. So that looks pretty good. So building and running again, let's just see what's going to show up in our simulator this time around. Oops, and I seem to, now this wasn't part of the demo, but I do know what's going on here. Basically, one of the challenges of working with the visual format language is it's really easy to get the format string wrong, and it's really difficult. The system doesn't help you out by checking that at compile time. So I'm going to go back into my board view controller, just have a little look at the, actually not into my board view controller, I'm going to go back into our ladder view, and our add size constraints method, just check out my formats again, and lo and behold, like I did in many of my demo practices, I forgot a closing parentheses. So we're going to try that again. Oh wait, and I might have actually forgotten too. Let's have a little look. There we are. So, okay, I think I've got an even number of parentheses there now. Let's try that again. Hopefully I haven't had it too many this time around. Okay, great. So using the visual format language, we've now gone ahead and created some size constraints. Our ladder is looking like it's on a much better place in the board. So that's very good. Now, quickly, we want to try and put some more obstacles on our board. So I'm going to go back to my board view controller, jump right down to the ladders section at the bottom of our file again. And I've already got a little method here that's going to do most of what we did for our right-leaning ladder. So creating a ladder, adding it as a subview. And we're going to go ahead and do the placement of the ladder on the board this time, not using plain old NSLAYOUT anchors, but actually a higher level extension that I created on UI View that just deals with some of the most basic use cases. So you can see here, like we had in our theory slides, a couple little methods, just taking different anchors that we might want to be working with at any given time, and creating constraints between the different anchors and between two different views. So I've got some basic scenarios: add center X anchor, add center Y anchor, left and right, bottom and top. So this is a scenario where you might not be interested in a third-party library, but you would like a little bit of abstraction above and beyond your basic NSLAYOUT anchor. So for this scenario, I'm just going to make sure I'm following my instructions. We're going to operate on the ladder view, and we're going to just call add center Y anchor to our view, and we're going to offset that a little bit by a constant. So the constant in this scenario is going to be negative square width divided by 3. And we're going to add a left anchor, to the incoming view. No constant needed for offset in this scenario. So we also have rotated this ladder a little bit by 20 degrees, which we'll see when we build and run the project. Oh wait, actually I'm getting ahead of myself. I haven't actually called this add left leaning ladder method that I've just created. So I'm going to jump back up to the top. In our add obstacles to board method, previously we had added let right equals add right leaning ladder to. So now we're going to add let left equals add left leaning ladder to, and just call that in our board. And I'm also going to add the left ladder that I've just created to our obstacles array. So let's build and run that again. Great, another ladder on our board, which is good. Now let's move over to add some snakes. So Command Shift zeros, I've already created a snake view.swift class. Scrolling down to the bottom, and much like our ladder view, we've got a little creation method here, factory method. So we'll pull that up, ready for use. Okay, and we've actually defined, as we saw a little earlier, Command-Shift-O and opening up the board view controller, we've actually defined some methods to try and add some snakes to our board, but they're not currently operational. So if we dive into the definitions of those, we've got part of the method kind of set up here, but we're going to need to add some AutoLayout bits and pieces. So here I'm creating a snake. The snake is going to be an orange snake because that is our default when we create a snake via snake view. And again, I'm going to go ahead and just make use of some of those higher level functions that I had previously created to do with our NSLAYOUT anchors. So I'm going to say add top anchor to our view, and in this particular snaky scenario, we're going to say constant is negative square width divided by 2. And then snake add center X anchor to view. So that's really good. Let me check that. That's good. We're going to command build and run, just make sure that our snake actually appears on the board. There we are, orange snake at the top of the board, so that's looking good. And finally, I'm just going to go ahead and uncomment some of these other snake methods that I have previously created to throw a few more obstacles up there. Great, Command R, build and run, and we should, with a bit of luck, get a bottom left snake, a green snake, and a purple snake. That's starting to look a little bit more interesting now as a snakes and ladders board as a game. Great. Now, the final thing that I want to look at in our demo number 2 is just take a look at what would happen if we rewrote some of the code that we've already created. So right in our original method, our add right leaning ladder method, we went ahead and used just regular old NSLAYOUT anchors to define the position of our ladder on the board. But I'm interested in knowing what things would look like if I actually used SnapKit to do that instead. So to make use of SnapKit, we've already incorporated it into the project using our pods. And so all I need to do to make use of it in this board view controller file is to say import SnapKit. We'll scroll down to the bottom again where we're actually operating in this add right leaning ladder method. And to make constraints on our ladder, all I need to do is say ladder.smp.make. And I'm going to hit return to autocomplete. I'll hit return to autocomplete again. We see that I need to provide a name here for our constraint maker class. So I'll just call that make, which is the SnapKit default. And then I'll go ahead and use make to create some constraints on our ladder view. So in this scenario, we're going to say center y dot equal to, view, and like we did before, we're going to have it offset by negative square width. So you can see that this line that I've just written here is logically equivalent to this slightly more verbose line that we wrote with our raw NSLAYOUT anchors. And then make dot right dot equal to view. Again, that last line that we just wrote, logically equivalent to this. And so with that, I'm going to press Command R to build and run. And all we want to check here is that our ladders haven't moved any, but that code is essentially doing exactly the same thing, and it is, which is great. So with that, we'll conclude demo 2. If you're just joining us, this is session number 5, AutoLayout Best Practices. We're just about to get into some debugging challenges with the AutoLayout, which is a bit of fun. So before we get into debugging, I think it's useful to have a sense of the different types of errors that you could encounter when using AutoLayout. And this is my best approximation of the 4 types that you might come across. First up, we've got ambiguous layout, and confusingly, some of these error types actually have different names in Interface Builder versus what you might see listed in Apple documentation. So, nice handy reference table. Ambiguous layout. Essentially, you've got missing constraints. The system doesn't have enough information in order to know where to lay out your view on the screen, and it starts to scream for help. Conversely, unsatisfiable constraints, also known as conflicting constraints in Interface Builder, is a scenario where you've almost provided too much information and it really doesn't know which bit is correct. And so, again, screams for help. It usually chooses kind of something to ignore or something to break. Third category, named slightly differently, my naming doesn't look quite right. It's basically a logical error. So you, as the person that has provided the constraints, expects one thing to appear on the screen. The system is happy. It feels like it understands, based on the constraints that you've provided, what it should be doing, and the constraint set is satisfiable. But in general, it's just not logically correct. It's not what you expect to show up. And then finally, perhaps the most difficult, rare and also difficult to sort out is performance issues with AutoLayout constraints. So it's been a long time since I've seen this one in the wild, but theoretically you can create a set of constraints that takes too long to evaluate in order for optimal rendering to occur in your iPhone app. And so in general, this tends to occur, or the last time I've seen it, the last time I was asking around, other people have seen it, tends to be in scroll views. So it is possible to generate a set of constraints within a scroll view that's difficult to evaluate, and as such, when you're scrolling, you're going to get some scroll lag, which is never good. What I would recommend is, if you do encounter this kind of rare situation, absolutely file a radar. Please tell Apple about it. That would be very useful. They'll probably be able to optimize something in there, but otherwise revert to manual layout in the meantime. So with those categories of errors kind of safely in your mind, these don't map one-to-one, but we've got some debugging techniques that we want to show you through today. I have named a lot of these techniques, not all of them, but a lot of them. And so we've got just redo it, visualization, drawing a line, and error message interpretive dance. And the last one there is what our little Swift character is doing on the screen. So just redo it. The general idea, and this is a general idea for persistent interface builder issues. So let's imagine that you've come along, you might have opened up a storyboard that you haven't opened up for a year, or a colleague has come along and done something funky to your storyboard since the last time you touched it. You might be ending up with a lot of errors and warnings when you open up that storyboard in Interface Builder. And so a couple of techniques you probably want to try. First up, have a look for duplicates. As we saw, it's really easy to press Command-C and copy-paste views and also constraints around the place. So you want to just do a quick scan and see if anything's duplicated, remembering that original principle of keeping things simple. Next up, I usually scan through the priority of constraints. So we saw some adjustments of constraint priority earlier in the tutorial. We changed something from 1,000, which is the standard priority, to 750. Usually people choose logical numbers. It actually doesn't matter what number you choose for your priority. It's only relative to the other priorities of constraints on your canvas. But if you saw, say, 742 or something like that, that might be a typo. That's a kind of an indicator that perhaps priority needs to be evaluated for all of the constraints on your canvas. Now, if that doesn't happen, you're still seeing weird errors, you're still seeing some weird behavior, you might want to just select an individual view that is causing you trouble on your canvas and use this menu. You might like to map it to a key command, but use this menu, editor, resolve layout issues, selected views, and clear constraints, just to kind of wipe out all of the constraints associated with that one particular view and reapply things. And we'll have a look at doing that a little later today. Okay, visualization, fairly vague category of kind of techniques that you can use in order to get a better sense of what's going on with your auto layout constraints. First, and something that we will look at in the demo, is using the debug view hierarchy view in Xcode. There's a really helpful tool at runtime to figure out what's going on with your constraints. You can also use an assortment of other runtime techniques that basically involve placing a breakpoint in various places and then spitting things out to the console, perhaps in visual format language. And then a technique that has been coined by Jerry Beers, AutoLayout guru, for Ray Wenderlich, called drawing a line. Let's talk a little bit about that one now. Cool. So this particular technique is based on the idea that if you have one view that is not operating as you expect, it might not be actually due to the constraints on that view, but a kind of poorly created or conflicting constraints from other views on your canvas. And so what Jerry is suggesting here is that for a view that is giving you trouble, draw a line through either the horizontal or the vertical axis, and then basically walk across your screen from one edge to another, inspecting all of the constraints that might touch that view in that particular direction. And if that doesn't work, give it a try in the vertical direction. So we won't look at that today, but I think it's a really interesting technique, and something that if you're feeling frustrated by auto layout, you really don't know what's going on, is a really good one to try, because it's got a nice logical progression to it. Cool. Final technique we'll take a look at today is error message interpretive dance. So, hands up if you've ever seen something like this before. Yep, it's not a lot of fun. This is a real error message from the Etsy app. My engineers might be pretty grumpy with me that I put this on the screen, but it was one that I was able to produce playing around in certain situations in our app. And it's pretty overwhelming. This is actually a lot longer, this error message. Really overwhelming. I really wouldn't want any of my engineers spending more than like 10, 15 minutes trying to kind of get a vague sense of what's going on. To dig much deeper into it is pretty stressful, pretty time consuming. What I'd really like to do is ask myself, WTF auto layout, which of course stands for why the failure auto layout. There we are, why the failure auto layout. And thankfully somebody, and I'm actually forgetting his name right now because I'm on stage, but I'll call it out later if I can look it up, has claimed this domain, WTFAutoLayout.com, and actually create a really interesting visualization tool that you can basically just cut and paste your error message into and get a much better indication of what's going on the screen. So from this, WTF auto layout will actually produce something like this. And this is the actual result of outputting that error message into WTF auto layout. It's not going to tell you exactly what your error is, but it's certainly a much more useful visualization of the problem. And if you happen to know now, based on this, why we have that error in my console, come up and talk to me later about the Etsy app. So with that, we're going to move into Demo 3 and take a look at some of these approaches that we've used. Now, similarly to last time, we're going to open up Demo 3 and the starter project for Demo 3, but we will again need to use Terminal. I'm really hoping that most people's Wi-Fi is up and running now, because we're going to need to move into the Demo 3 starter folder, and again issue that pod install command. Great, and having done that, I'm going to open up this workspace file. Cool. So, like last time around, you've got to imagine with this demo that a rogue colleague has come along and has both added some new functionality to our Snakes and Ladders app, but also created a bunch of issues accidentally. And so what we're going to go ahead and do is press Command R to build and run the project with one eye kind of on the simulator. And here we are. That's what I wanted to do. Thank you for Tammy for that little pro tip. I've been trying to resize my simulator for a little while now. Now, you'll see that the app crashes, and this is to be expected. So this is your worst kind of auto layout issue that crashes your app. You've got no idea what's going on your screen, and you've really got to resort to error messages and taking a look at error messages. So we're going to open up this error message console a little bit more and just scroll back up to the top. I have a habit of closing and restarting the simulator, so I'm going to stop the simulator just while we're looking at these error messages. And we see that there's kind of two groups of error messages. There seems to be one group up the top here, and we've got a UI segmented control that we're taking a look at. There seems to be some errors around that, but it's not what's crashing our app. So I'm going to scroll down to see where the crash is happening, which is just here. And kind of above that, the system is trying to help us out to tell us what's going on. So reading here, it says terminating app due to uncaught exception, blah, blah, exception. It can't activate some constraints. That's pretty understandable given that the app is crashing. It's talking about the two different views that are involved, so a piece view and a board square view. So the board square view, you'll remember, is one of those squares on our checkered snakes and ladders board. A piece view, I can only assume, I did write this tutorial, but let's imagine I can only assume that this is a piece, a player piece that we're trying to move across the board. And there seems to be something going on when we're trying to create constraints between those two. So that's about all of the information that I'm going to get out of that error message, so I'm going to put that away for the moment. I'm going to hit Command-Shift-O for orange and open up board square view controller, because we know from previous demos that this is the main view controller of our app. And if something is crashing on launch, view did load, view did appear, some of those view lifecycle methods are probably the best place to start. So let's have a little look at what we're doing here. So in view did load, I have set up pieces. And because I've looked at a piece view previously, this seems to be a good place to start to have a look. So I'm going to have a look in the definition of this method. That was just control-click and moving into the method definition. I can see here that I am defining the size of my piece view, again, relative to the square width of my board. We have player number one's piece is a little star. Again, shout out to Vicky Wendelich for the artwork. Things are going to look a lot better due to her artistic abilities. And then once I've created my piece views, I'm actually adding them to this pieces array. A little later on, if I scroll down, I can kind of see that I am trying to make sure that our pieces are on top of the board and kind of placed on that starting location. So we're actually moving them to a start location. And if I click into this move method, I'll notice that I'm doing some constraints adjustment to actually set them up in the right position on my board to start with. Now, given that this is where we're adjusting constraints, take a quick look at this. We seem to be making some constraints using SnapKit. That's fine. That all looks good. But what I have realized looking through all of this is that when I am, and oops, I'm just going to hit back a couple of times till I get back to my board view controller file. It seems like although I'm setting up these pieces, I'm never actually adding them to the board in any sense. And I suspect, given that they're talking about referencing anchors and constraints in different view hierarchies, if I haven't added the pieces actually to the board and I'm trying to create constraints between them, things probably aren't going to work very well. So I'm going to go ahead and try and fix that based on my hunch by saying board.addSubview and adding player 1 to the board. And then board.addSubview, adding player 2 to the board. So cross your fingers, we're going to build and run again. Just take a little look at what happens this time. I'm going to count to 3. When I count to 3, I see nothing has crashed, so that's good. We've made a little bit of progress, but as you can see, our snakes and ladders board is looking kind of as we left it in the middle there. We've got some weirdness happening up here with this UI segmented control. It seems to be trying to tell us if player 1 or player 2's turn is happening. And this dice image doesn't look good. It's flying underneath the board. However, I do notice that if I click/tap on the dice image, I can actually execute a move on the board. So I've rolled the dice. The dice seems to be giving me back a number, which is great. But I can't then, when the pieces are going to kind of try and move across the board, all of a sudden the board disappears. And this is really, again, not what we want. Pretty problematic kind of auto layout issue if your entire view is disappearing. So we're going to have to, again, resort to some of the logging and some of our consoles to figure out what's going on here. So try and keep this image in your mind. I'm going to close down the simulator. I'm going to just catch up to my notes here. And in general, I open up and see we've got about a zillion error messages now happening, which is always fun. And what I'm going to do now is go ahead and use WTF AutoLayout. I'm just going to make sure our Wi-Fi is working by refreshing that, and just see if it can help me make any sense of these errors that are happening. So, grabbing the, and basically want to grab from the open parentheses here down to the bottom parentheses here. You see that this is actually some attempt at VFL in here, and basically what WTF AutoLayout is doing is trying to translate from VFL into a more visual format. I copy that by pressing Command-C and just pasting that constraint log in. And okay, good. I'm getting some slightly more useful information, and I'm just going to scroll through this looking for bits and pieces that interest me. So anything that stands out is really what I'm interested in here. What doesn't stand out, or what I'm not super interested in, is anything to do with the board square views. So setting up of the board square views on the board. I feel like because my board renders correctly initially and I place pieces on the board, something to do with the movement of pieces across the board rather than the board constraints in general that are probably causing issues here. So I'm going to scroll down for anything that doesn't look like a board issue. And we do start to notice that piece views are referenced here. And so it seems pretty reasonable if I've got two piece views on my board that one might be trying to horizontally center equivalent to one board square view. And the second might be trying to center itself given another board square view. That seems pretty reasonable. If I scroll down, I'm not really getting a lot out of the other error messages. So I'm going to actually move along to just another randomly chosen error message through this console. Now, you can see there's a ton here, so I'm going to pick and choose a little bit. What I would do in practice here is basically throw all of these error messages in, just looking for anything that seems to stand out. So let's do that again. I don't think, we'll just go top to bottom for a little bit of sanity. Again, just copying and pasting this error, throwing it into WTF AutoLayout and just seeing whether that gives us any clues. So scrolling down. So this is starting to be a little bit more interesting. Previously we saw that we had two piece views and they had previously had constraints associated with board square 1 and board square 2. But here we actually have a piece view starting to be trying to be associated with board square 3. Now, if we've only got two pieces on the board, to have constraints with three different separate board squares seems to validate the idea that it's something to do with piece views, because we should only really have constraints between one piece view and one individual board square at a time. So that gives us a bit of a clue. And with that clue, I'm going to kind of move back to our code. I'm going to have a little look in the board view controller. We have a method called roll dice tapped, and just kind of see what's going on when the dice is being tapped and see if we can figure out what might be going wrong with our constraints. So when we tap our dice, which is that dice image on the board, we basically generate a result for that dice, and then we try and animate some stuff relative to that result. So if you rolled a 6, we try and move some pieces forward 6 on our board. So we're calculating a final location, retrieving a final square, preemptively kind of updating some locations regarding our current piece, and then trying to move things along and changing turns at the end here. Now, I guess I'm most interested when we're actually moving pieces on the board, so I'm going to jump to the definition of that. We're adjusting some constraints to move a piece, which is kind of interesting given that constraints are causing this issue. I want to dive in there. And now looking at this again, the first time around I didn't really notice it, but we're going to, each time we're rolling the dice and trying to move an item forward, we're creating a new set of constraints between a piece view on the board and a new board square, which means that if I roll the dice and move the piece view forward 2 spaces, and then roll the dice again and move the piece forward 2 spaces again, I'm going to have 2 separate sets of constraints when I only really want the last set of constraints. And so that's because SnapKit here is just making constraints and then making more constraints again. I happen to know, mainly because I wrote this demo, that SnapKit also has a method called remake constraints that's actually going to remove the old constraints and add the new constraints in place. And so that's actually what I want to be using here, not remake constraints. Okay, there we are. Just a little casing error there. So instead of make constraints, I'm going to update this to be remake constraints. I'm going to build and run again and see what happens. Great, board is there as it was before. The true test now is if we tap the dice image. Okay, so I start to see now that in tapping the dice image, pieces are moving across the board, simulating turns. I happen to notice that our segmented control is moving back and forth, indicating what turn is taking place, so that seems to be good. So I'm going to consider that particular hiccup corrected. And we'll move on to the next one. I'm just going to remind myself which one I was going to do next. Yep, so the next issue that we'll take a look at is why the segmented control at the top of the view here looks so ugly. So basically, this we'd much prefer it to be kind of centered and providing us with some more useful information. So we know from earlier demos that the main storyboard is Command-Shift-O main.storyboard. I'm going to go ahead and take a look at this storyboard, and already we see in the top left-hand side here we've got an error happening, and I'm going to dive in and kind of take a look at those errors a little bit further. So untwisting some of these twisties just to see what's going on. You can see that I've got a top container here, and I've got a segmented control contained within that top container. And then if I take a look at my errors, this is kind of a weird set of errors. I have both conflicting and missing constraints, double whammy. And some of these aspect ratios look kind of weird. I don't really know a scenario of which I would need a 23:4 aspect ratio for a UI segmented control. Just for kicks, sometimes we'll try things that we think might be easier for ourselves. I'm just going to try and use one of these auto fixes and see what happens. Now, when I do that, yeah, my UI segmented control is looking much worse, which is not what I want. So I'm going to hit Command-Z to undo that action. Command-Z if you're from Britain or Australia, but Command-Z for everybody else. And instead of using this, I've really decided that I'm going to just give up. Oops, I'll move, which is... Oops, let's try that again. Open up our storyboard. We're going to give up, which is okay in an auto layout constraint situation. I'm going to just select our segmented control. I'm going to say Editor, Resolve Auto Layout Issues. And under this selected Views menu, I'm going to say Clear Constraints, because I'd really just like to reset the constraints for my segmented control quickly and easily. I kind of know what should be happening, and I don't know why there are so many weird other constraints. So with that, I'm going to control drag between our segmented control and our view. And I'm just going to say, holding the Shift key, then click Center horizontally in safe area, Center vertically in safe area, and hit Return. And whoops, actually that's not what I wanted to do. That's probably what I did in demo 1. Muscle memory is a serious thing, so let's just again hit Command-Z to undo that. Try that again. We're going to control drag between the segmented control and the top container. And this looks a little better. I'm going to hold the Shift key down, click Center horizontally in container, and Center vertically in container, and hit Return. Okay, so that's looking better. You'll see there's still a couple of warnings, so we'll zoom over here to the little warnings, fix it. And I'm just going to hit this little helper here that's going to allow me to update frames, and I'll click Fix Misplacement. So that's looking a little better in my canvas now, so I'm going to build and run. Just see how it looks in the actual app. Yep. Great, a little better. Okay, so we're going to consider that usable for the moment in my simulator. A little resolution issue, I think, happening, but we'll just press on. We're almost done with the tutorial, which is great. Okay, and so I'm going to zoom back out in Xcode, hit stop to stop my simulator, and the next thing that we're going to take a look at is why our dice image, you see the dice image at the bottom here, is really not looking too good. So we want to make that a lot more usable, a lot more tappable, and not hiding underneath the board. Okay, so to do this, actually I'm going to stop that for a moment. We'll take just a very quick peek at the different constraints that are applied to this dice image. So in our bottom container, we've got a little dice UI view here, which is what we want to take a look at. And over in our right-hand side, let's scroll down, there's quite a few constraints being applied to this dice image. But we'll see here that the width, there is a width constraint being applied. We have a 1-to-1 aspect ratio that's being applied, so that all seems pretty good. And I will notice at this stage that our dice image seems to be looking pretty good on our canvas, but it's not looking good when we actually run the application. And as a result, I won't dig around too much more here. I'd like to actually inspect a little bit more closely what's happening when I run the application. So we'll just hit run on the simulator again. And I'm actually going to make use of this little icon here. I click that. This is actually the, scrolling back out, the debug view hierarchy feature of Xcode. Really cool. I really enjoyed this with the snakes and ladders board because you can actually drag and see all the different views that you've got in your application. And it works really well with this nice little checkerboard effect. So you can kind of peek behind what you've placed on your canvas and see, sometimes that'll help you figure out what's going on. Letting go when you're dragging around there will just have things snap back into place in general. So there we are. Now that's probably not going to help me for this dice image. I can get a nice kind of visual of what's going on with the board, but not the dice image itself. So I'm going to go ahead and click on this UI image view, which we notice is the dice image over here on the canvas. Scroll that into view a little better. And then under the constraints, I'm going to go ahead. We've got a bunch of constraints again being applied. I don't love, for whatever reason, I don't love looking at the constraints in the left-hand pane there. I much more enjoyed looking at them in the right-hand pane. So I'm actually going to double-click. Whoops, try that again. Let's go back. Just go out of this focus mode here by clicking on the little X. Try that once more. And actually, what I'm going to have to do, I think, is, yeah, I'm kind of in a weird view. I'm just going to stop the simulator, run that again, start that process again to go back into the debug view hierarchy view that I'd like. Great, so that's back. I'm actually going to click on this once. And what I actually wanted to do, much better here, is go over here into this little size inspector. Now this is actually giving me information about what's happening at runtime. And you'll note here, what catches my eye most immediately is the fact that our width and height is actually 300 when we're running this, but we did notice that we placed a width constraint of 150 on the dice image. So why is that happening? Can't answer that just at the moment. I'll also notice when I scroll down that we don't see the 150 constraint kind of mentioned here at all. So that's a clue as to what's going on. With that information, I'm going to get out of our debug hierarchy view because I actually want to go back to my canvas and kind of inspect that particular constraint a little bit further. So I am going to, again, click on my dice image view and then go ahead and this is our constraint that's kind of in question at the moment, given that we didn't see it activate correctly. Double click on that. I'm going to really inspect the properties of this width constraint. So we'll notice that the first item involved in this constraint is the dice.width. That seems to be pretty good. Relation is equal. That seems correct. We've set our constant to 150, which is what we expect and what the canvas seems to be rendering here. Our priority is 1000, so it should be being activated, so that's great. We haven't provided an identifier for this constraint, but that's okay. We actually don't need to reference it by name in any sense or by identifier in any sense. But here is something that looks a little bit more suspicious. So we've got this remove at build time, or my colleague or myself has accidentally placed this remove at build time check onto this particular constraint. Now we want this constraint to be active at build time, and as such I'm going to uncheck this checkbox. And with that, I'm pretty confident that that's going to improve the situation. So I'm going to build and run the application again. There we are. And so finally, our little dice image is looking a lot better. So I'm going to click that. And now if you have been following along, you can play a couple of rounds. Basically, when these icons encounter an obstacle, and I'm really hoping it will, though it is pretty randomly generated, they'll actually handle that obstacle accordingly. So as you can see there, the little purple snake, when I think this is player number 2, when player number 2 encountered the head of the snake, it slithered back down. And it's the basic premise of ladders and snakes. If you encounter the head of a snake, you'll slither back down to the tail. If you encounter the bottom of a ladder, you're going to march back up to the top. So, with that, Demo 3 is complete. You're welcome to play a couple of rounds of Snakes and Ladders if you like to, just to see what happens if you finish the game. And actually, we're leaving it as an exercise for the reader or the tutorial attendee to actually, if you'd like, to take a look at putting some animations in when you finish the game. But with that, we'll move back to our slides. I might need to coax Keynote into working. There we are. Excellent. So, in conclusion, what have you actually learned today? So, quick recap. In demo number 1 and part number 1 of this tutorial, we've looked at AutoLayout with Interface Builder and a couple of tips and techniques that you can use to make things a little bit easier. Some key commands, some stack views, some dynamic type. Demo number 2, we've looked at a lot of different ways that you can create auto-layout constraints in code, some of the pros and cons of using each approach, and some of the techniques you might use for smaller code bases, larger code bases, or if you really like the VFL language, some of the challenges involved in that. And in demo number 3, we've looked at a couple of different categories of auto-layout error, and also some of the techniques that you might use if you're feeling really stuck to try and debug auto-layout in a couple of pretty tricky scenarios where we're not getting a lot of information from our views as to what's going on. So, with that, if this has really piqued your excitement for further auto-layout, good news, we have a lot of material on auto-layout on the Ray Wenderlich site. We have beginning auto-layout that was recently updated by Jesse Catterwell, one of the team members. We have mastering auto-layout by Jerry Beers, who's done a lot of the Ray Wenderlich auto-layout content in the past. And we've also got a really interesting and quite long article from the obc.io folks. It's called Advanced Auto Layout Toolbox, and if you're really looking to get into the depths of auto layout, highly recommend that article. And of course, I would highly recommend you check out WTFAutoLayout.com. I have no affiliation with this particular site, but I think it's really excellent, and I think it's somebody's side project, which is really cool. On the internet, you can find me at Gemma K. Barlow, Twitter, all of the internets. And with that, I conclude, and thank you very much for attending.